So we're still investigating pH because it's important and it influences so many systems, whether it's you're trying to make gum or living systems, metabolism, what's going on in a garbage dump. I mean, pH controls a lot of different things. So not everything's a strong acid, so we started talking about weak acids because there's a lot more of them. But then there's some compounds that are basic. So, because not everything's a strong base, you also have weak bases. So that's what today is. We're going to have some weak bases, and we're going to try to investigate and predict what the pH will be. So how do you recognize you've got a weak base, Monica, in the first place? How would you know it's a weak base? Oh, good. That's perfect. If it's not one of the strong bases, okay. And for us, it's going to be narrowed down even more today. It's in the table. It's got to be one of these guys. Okay. So Monica's exactly right, though. It's not one of the strong bases, but for us right now, it's going to be in the table. And we'll get more general in the next class period, but then she'll be right on. So we talked about how to write a acid. We talked about how to write an acid ionization reaction, right? Remember that was just HA going to H plus and A minus, right? That was the general way for acid ionization. And you had to write it that way. Otherwise your Ka isn't going to work, right? So likewise for base ionization, how does a base control pH? We have to write an equilibrium for bases, and we have to write them everyone has to write it the exact same way. So you grab a base from the table, right? Anyone, doesn't really matter. You add it to something, you get something and something. Now what are you going to generate? For sure, it's a base, so you better generate what in water? It's a base. Oh yeah, the conjugate acid is a good one. But when I think of base, I think of what? A lot of OH. So you got to generate OH. And Brad's exactly right. The conjugate acid. Yeah, so exactly what Vante said, H something, right? So what is it reacting with, though? Here's the hint. You have the OH, and then Vante said the H something. HOH is what you're adding. Water. All right? And I guess we should have little AQs on all this other stuff. Okay. So how should we write the equilibrium constant? They call it the base ionization constant, Kb. Now notice again, there's a subscript, that B. So that means you have to write the reaction how we did it up there. It would be what over what? How would you write it, Desiree? How would you write that Kb expression? Oh yeah, sorry, I was looking at the wrong one. And the conjugate acid. And on the bottom, oh yeah, not the liquid, not the water, just that base. The base from the table. So do we have to memorize all these bases? No, you just know how to use the table, right? So where do you get these Kb numbers? Everybody, you get them where? Yeah, from the table. You got to be given the table. Look, there's even all their formulas, right? And to write their conjugate acid, what do? Vante, say it louder. Well, technically an H plus, right? Is how you write the conjugate acid. And they'd like to see it out front. Okay, let's write the hydrolysis reaction for ammonia and write its corresponding equilibrium constant expression. Okay. Gloriana, how would you do this? I'll give you the arrow. Show you the hint there. Exactly. It's got to be an H2O. Yeah. And it's for NH3. So the NH3 has to go where? Yeah, its conjugate acid will be a product. But the NH3 itself, the base is going to go on the left. Okay, now let's let someone else finish this. Jacqueline, what's the other product? HNH3 plus. Exactly. Or you could write it what way? More common. NH4 plus. It's the same thing. It really doesn't matter. Right? Okay. Oh, we need to write its equilibrium constant expression. Since we wrote, there's the equilibrium constant. Since it's the base hydrolysis reaction, you should really put a little B there. Products over reactants. So Brad, what'd you write there for the KB expression?
The concentration of your hydroxide.
Yeah.
Concentration of your NH4 all over the concentration of your NH3.
Yeah. Exactly. Everybody agree? Okay. Here we go. Find the hydroxide concentration and the pH of 0.01 molar C5H5N. And Kb for it is 1.4 times 10 to the negative 9. So this guy must be in the table, right? And I looked up the Kb, the other column across from it, and there's my Kb number. So Marlena, I was going to Google this song. Can I figure out a way illegally how to get free music? Shouldn't have this on. But the song I was going to get is blank, blank, baby. Right? Ice, ice, baby. Because that's what we're going to do again, right? I could. Is it really? Okay. So Vante, what reaction are we going to do ice, ice, baby on here? C5H5N. Keep going. Plus H2O.
And then on the other side it's going to be H plus or H? Yeah, H plus.
Not H plus. Has to go to OH minus. And
HC5.
perfect. Throw that H out front. He says HC5, right? And he said the plus. Good, right? So this is, you have to write the reaction that way. Has to be the base plus water gives hydroxide plus the conjugate acid. All right. So, Angelica, we're supposed to do ice. So I'm going to put in the stuff here. How are you going to fill out your ice table? Good. Yeah. In fact, what would be a good idea? Does anyone see what I'm going to say? Under that H2O, all the way down, put what? A line, a dash, cross it out, I don't care. Because it never shows up. You don't want, otherwise you're going to, right? See what I'm getting at? Okay. Let's, Angelica. Danielle, finish the ice table for us. Negative X. Ah. Yeah. And then 0.01 minus X. X. Okay.
There's the number always in front. That's
And then we can do our shortcut here, right? Since it's
Yeah, Brad's looking ahead. We're going to be able to do a shortcut because we have 10 to the negative 9. And we want concentration of hydroxide. So in our ice table, that answer is just going to be what? It's going to be X. All right, because here's all of our answers. All right, just trying to look ahead a little bit. Here's all of our answers. So if they wanted to know the concentration of hydroxide, it'd be X. If they wanted to know the concentration of the conjugate acid, it would be X. If they wanted to know, well, what is that thing called? C5H5N. 0.01 minus X, but essentially just 0.01 because X is going to be really tiny. What if they want to know pH? Oh, and they do? Yeah, they do.
do the 14 conversion. KW
Oh.
times
You could, you could,
do with the plus.
right? Do you remember that, what he's talking about? You could do the KW equals hydrogen ion concentration of hydroxide. You get the hydrogen ion, take the negative log of it. Or do the pH plus POH is 14, right? So fill it out, right? Write your KB expression and do the shortcut that Brad was talking about because we have 10 to the negative 4 or smaller. Kelly, did you get an X? Did you get an X yet? What did you get for your X? 3.7, 10 to the negative 6. Anybody else get 3.7 times 10 to the negative 6? Good deal. 3.7 times 10 to the negative 6. Big M. Okay. Did everybody get it? All right, so she must have took 1.4 times 10 to the negative 9 times 0.01, then took the square root. Right? There's Brad's shortcut, right? Drop the negative x. Because we have 10 to the negative 4 or smaller. Now, the concentration of hydroxide, that answer is 3.7 times 10 to the negative 6. Okay, that's what he is. But they want to know pH. So I kind of like the pH plus POH equals 14. I think it's easier. Because that number is already in your calculator, right? 3.7 times 10 to the 6 negative is already in your calculator. Take the log of it, and you'll have POH, right? POH is the negative log of 3.7 times 10 to the negative 6. And that's 5.43. And then to get pH, remember pH plus POH is 14. So that means that pH would have to be, I'll just add 14 to that since it's already negative in the calculator. I get about 8.6. Okay? Well, 8.57. Yeah, I'm just rounding up.
Now, just out of curiosity, when we write these down on our tests and stuff like that, can we abbreviate it like we did the acids? Like whenever we do an acid, we don't include the H2O. Can we just go same as one C5H5N and then go OH? C5.
You mean when you're writing the reaction?
Yes.
No. For the reaction, you have to write it. The only thing you could abbreviate, because Brad's saying, what could I abbreviate, make things go faster? What you could do is you could write the reaction as A minus plus H2O gives OH and HA. Right? That's about the only shorthand that you can do. Right? But it would still give you the same answers. Okay. But yeah, you really can't shorthand it much more than that. Okay, let's see if you can get the answers to number 3 here. Find the hydroxide and pH of 0.05 molar C2H5NH2, and I give you the Kb. I'm sure glad we decided on the 10 to the negative 4. Right? Now, some folks have already noticed that when you do the little shortcut with the 10 to the negative 4, the answers in the back of the book differ like maybe by 0.1 or 0.2 decimal place. But, you know, that's fine. They just did a full quadratic. We're still really, really close. If you're not sure on how to do EX2, the one we just did, getting pH 8.6, just ask. Make sure you're clear on this stuff. I'm going to cheat here. Marcus, what'd you get for your X? 4.8 times 10 negative 3. Anybody else get that? Good. It's nice to be able to just ask and I don't have to do anything. Now remember, that's your hydroxide. So .32. All right, everybody agree? around 12? Wow, 11.68, 11.7. Okay. Let's check out this question. Separate 0.25 molar solutions of each of the following bases are prepared. Place a circle around the solution that will have the lowest pH and a box around the one that will have the highest pH. Jalen, you have a game plan for this? Not really? That's fine. Okay. Now, yeah, does it have to do with what? Now, you're looking at these compounds. They're all found where? In the table. Now, that's a hint. They're all found in that table. So, that's one hint. And the other hint is that the lowest pH, let's look at that one first. Lowest pH. Does that mean the most what? Lowest pH means the most acidic or basic? The most. Remember how that works? pH 7 is neutral. Really low pH means it's acidic. Coca-Cola. It destroys teeth, right? Okay? Dissolve your teeth. So lowest pH, that means most acidic.
For basics.
Yeah. Well, most acidic solution. And then the highest pH will be the most basic. Okay. Now we're just talking about bases. So if we say most basic, that means it's going to be the strongest or the weakest base. It's the most, you put this guy in solution and his pH is the highest, he's going to be really basic, but is it going to be the strongest or the weakest base? Strongest, because everything else, if it's a little bit weaker base, the pH will be a little bit lower, right? It'll all be above 7, but, okay? So how do you tell, looking at a table, without going through all the work of calculating the concentration of hydroxide? You don't want to go and do that for everyone, right? Because you could go calculate the concentration of hydroxide, do an ice table for every single one of these, but you don't have to. What do you go by? Not the H's. Go by the KBs. Because look at your reaction of the KB reaction. Right? Here's your, let's go to, where is it? Here it is. There it is, right? There's our KB reaction, right here. The bigger KB is, the more what? The more dissociation, the more basic, the more hydroxide, the more OH. So that's all you go by. If there's a really big KB, if one KB is bigger than the other KB, that's bigger KBs, stronger base, because more hydroxide. So that's all you do, is list these bases, right? Maybe scribble their KB under each one, and then find out the one that's the most basic, and he gets the box, and the one that's least basic, he gets the circle. Right? I'm too lazy to go back and look at my table. Let's ask Israel what the heck these numbers are going to be. What number do you what KB do I put under these? For under yeah, for the N2H4. 1.7 times 10 to the negative 6. And the next one?
1.8 times 10 to the negative 5.
Okay, thank you. And you can keep going.
1.7 times 10 to the negative 1.
Okay. Did you have time to do the last one?
1.4 times 10 to the negative 1.
Okay. Does everyone agree with those numbers? Okay. Back to Monica.
Yes.
Let's do well, it says place a circle around the solution that have the lowest pH. All right? The lowest pH. So that means the strongest or the weakest base? The weakest. So we're going to circle the weakest base, and that one is Desiree. Which one? Which one's the weakest base? So are we looking for a big KB or a small KB? Weak base. So we want a small. Right, we want a really small, the smallest KB we can get. And 2H4. So we should, hopefully everybody circled this guy. Okay. Put a box, Jacqueline, around the base that's going to give the highest pH. And that will be which one? She says the C2H5NH2. Yeah, because that's bigger than 4.7 is bigger than 4.4. I agree. Okay. So if you want to compare bases, you can always do ice, and go ahead and actually calculate the pH. But if they're just comparing strengths, just look at the KB and stop there. Here's the big test. Big test because I don't have any other problems. This is the last one I've written. I have to make up some more, but maybe this will take a while. We'll see. If the pH of a solution of C5H5N is 10.25, what is the concentration of C5H5N? Now, we had some homework like this today. That was due today. Yeah, you're kind of going backwards. See if you can figure it out. And then if you're onto something, we'll have you explain it. The numerical answer is given. One thing's kind of curious. I don't know if you noticed this, but it kind of follows with the last example. The KB for this thing is 10 to the negative 9. Does that mean it's a really, really weak base, or really, really? So look how concentrated it needs to be, 22.6 molar, to get the pH just to 10, right? So it kind of follows. But anyway, see if you can figure this out. They tell us the pH, and they want to know what the concentration is of this stuff. We'll give you a few minutes to try to figure it out, and then we'll work on it together. Bless you. For me to just give you a hint, for me to visualize the answer, I have to do an ice table, but it's really not much of one that I can fill out too much, but it helps me. Bianca, did you get an answer? Really? You got the 22.6? How'd you do it? Oh. So you got, okay, you got your X. So you got this. And then then you found that him. And then, you did all that without an ice table. Man, you can visualize it better than I can. Look at that, she did it without an ice table. Yep. Bianca got it. Okay. So then 10 to the negative POH is hydroxide. So 10 to the negative 3.75 would be hydroxide.
That's what I did, but I'm not sure that's
No. Put 3.75, make it negative, and then it has to be shift 10 to that power. Okay. So, anybody else figure it out besides Mark? Did you get it? 22.6? Okay. Now, to work this out, well, I think Glorianne or someone said at the beginning, you work backwards. She's right, because they give you pH. So that means you really know what your X is. Well, right? But OH is your X. Exactly. Good point. OH is your X. So it's not gonna be quite as straightforward as the homework was, where you figure out what your X is just by 10 to the negative pH. So what I suggest doing is, if they give you a KB, go ahead and write the KB expression, the KB reaction, and it kind of guides your thoughts. At least it does for me. So my KB reaction would be, Glorianne, how did you write the KB reaction?
I wrote C5H5N
C5H5N
plus H2O.
plus H2O.
And then on the product side, OH minus.
Yeah.
Plus HC5H5N.
Yeah. Well, technically with a plus, but okay, good, very good. And then, okay, so we really don't know what this stuff is going to be, but we could, right? If you wrote the KB, that's going to be what? 1.4 times 10 to the negative 9. And that's going to be hydroxide times H, right? Okay. And you probably don't need to write all this out, but okay. The reason why I guess I wrote it out is because they told us you need the concentration of hydroxide. Well, you really know what it is. Because if they tell you this is pH, you know what POH is, right? pH is 10.25, so POH has to be what? It's 14 minus 10.25. 3.75? Okay, 3.75. Now, do you remember the trick in going from, once you know POH, concentration hydroxide has to be 10 to the negative POH. Just like hydrogen ion was 10 to the negative pH, hydroxide is 10 to the negative POH. So 10 to the negative 3.75. Okay, so where's that? What is it? 1.78 times 10 to the negative 4. Okay. Now, life might be a little bit easier if we finished in our ice table, because right off the bat, though, you know that hydroxide is 1.78 times 10 to the negative 4. Now, if you're comfortable with this, and you've done a gazillion of these problems, this conjugate acid is also 1.78 times 10 to the negative 4. So you're really 1.78 times 10 to the negative 4 times 1.78 times 10 to the negative 4, right? And then you just solve for him. And you'll have it, right? Now algebraically, let's finish this so we can see the math. The math isn't that straightforward. So we'll have, because notice if you filled out the ice table, you'd have dashes, dashes, x, x. So these guys are the same. They're the same number. So that's why it's going to be 1.4 times 10 to the negative 9 all over, like you said, just square it. Whoop, 1.78. Square it. Okay. But you don't want to, you get this far, do all that work. Oh, Marlena, how do you solve for this? Exactly. See what she said? She's going to take the 1.78 to 10 to the negative 4, and we'll square it, then divide it by the 1.4 to 10 to the negative 9. Because you're just doing that diagonal story, right? Switching them. C5 H5N is going to be 1.78 times 10 to the negative 4. You got to square them, divide it by 1.4 times 10 to the negative 9, and you get what, Gloriana? Oh, that's right. That's our answer, 22.6. Okay, it should work out. Okay. It's a tough problem. Yes, the table you're going to be given. Table you'll be given. So to do all the homework, you really need that table accessible, right? Because it gives you all the KVs you need them. And just make sure you write the base reaction the right way. Base plus water gives the conjugate acid plus hydroxide. Then do ice, and it'll work. Okay? So come by if you have some questions. I'll be glad to work with you and help you out.